Space station is testing a robot mechanic that one day might be dispatched to perform simple repair tasks on orbiting satellites. It's called RRM. Lori Meggs with the station's Payload Operations Integration Center in Huntsville spoke with scientists from NASA's Goddard Space Flight Center working on this technology demonstration on this robotic refueling mission.
Just like if you were to go put fuel in your car, you have to open up your gas cap, put in the fueling valve, transfer the fuel, close it up and go. Same thing on a satellite. Satellite fuel valves are closed out with a series of caps and wires for ground safety. So in order to put more fuel into a satellite, you have to cut those wires and remove those caps and then install a refueling tool, transfer fuel, and again close it out. Same as if you want to do it on the ground with your car.
Right now, satellites are designed to not be serviced at all. They're closed out on the ground and never to be touched again, which was part of what we wanted to do with RRM, which was demonstrate that we could actually interface with those, for example, fill and drain valves, electrical connectors, MLI. If we can interface with these things that weren't meant to be serviced, then we could prove that we could go up to the existing satellites and service them.
We built a series of unique and innovative tools to utilize the robot on the International Space Station. Dexter was intended to do maintenance on station, move an ORU or a box from one location to another location. So we studied that robot and determined that we could build innovative tools that the robot could grab onto and remove these caps, cut the wires, and again transfer the fuel. We have 4 tools on board. One is what we call the multi-layer insulation tool. It cuts the wire, it grabs onto the blanket. One is called a safety cap removal tool. It grabs onto the safety cap on the fuel valve and removes it. So one is our refueling tool that's designed just to thread onto the fuel valve, transfer the fuel. And then the other one is what we call a multifunction tool. It's just like a standard socket wrench that you'd use in your garage. We designed it so that we could fly multiple adapters or sockets like you would use in your garage, and that way we don't have to have more tools. We have the one tool and can fly smaller adapters. So again, like I said, it's modular. If we want to continue multiple iterations of the technology demonstration, we just have to fly new adapters, and we can continue using that one, what we call multifunction tool, to manipulate these adapters with the robot.
The first round of tools that we had were great, but we learned a lot of lessons and improvements in how we could make them easier to operate for the robotic operators on the ground and also more efficient at their task.
What kind of results have we seen?
So far we've had phenomenal results. Everything has really gone as planned, slower sometimes. We found that alignment is key. So, we work very closely with the robot operators at the Johnson Space Center during real-time operations to ensure that the alignment aids that we've put on the tools and the alignment aids and overlays that they have on their screens are where we want them to be. But there's been still a couple of things we haven't predicted, but we've been able to work through all of them and successfully completed all of our tasks. From, again, the first series was removing caps and cutting wires, just kind of getting our feet wet. And then the second series was doing the end-to-end refueling, where we cut all the wire, removed all the caps, and did the eventual refueling. And then the third set of tasks is what we call our tertiary tasks. It was manipulating blankets. It was, we manipulated some number 10 torque sets, just small screws, not designed to be done with the robot again, but showing that the robot could align itself onto a small fastener or screw, remove it, and put it back in. So just trying to give the community a flavor of what's available with robotic servicing technology.
The next step would be developing interfaces for the satellites that were designed to be serviced. So by putting, for example, a target on that a robotic system could use for alignment, putting in a valve or something else that had a more friendly robotic interface on it, something that was more easily adaptable to a robotic system, whereas now those interfaces are designed for interaction with human hands, which is obviously much different than the robotic systems that we have. It benefits everybody. NASA is very interested because they can use the technology in order to service and upkeep their own satellite fleet, in addition to the commercial industry who can utilize the technology for their own purposes and their satellites. And by having those organizations utilize the technology, it benefits everybody else here on Earth. All the different satellites that are up in space right now that do things like satellite TV, weather, things like that. If those satellites can be better serviced, and if we can develop an ecosystem where satellites are capable of being serviced on a regular basis and not just replaced once something breaks or they reach their end of life, then it becomes a cheaper and more efficient system that everybody can take advantage of.